We're now going to find the inverse function of 2 times x minus 3 squared plus 2. Well, we're going to find the inverse of it. It may or may not be a function. So again, number one, we'll write g in Leibniz notation. Y is 2 times x minus 3 squared plus 2. 2. Identify that this is the inverse, and we swap x and y. And finally, step 3, we're going to isolate y to explicitly state our function. Okay, you may want to pause it for a second to make sure that this is right. I swapped sides and then I added 3 to both sides to get y by itself. This is correct, but if you're watching this, you may want to pause this to verify that this line is equal to that one. At this point, it splits off into 2 separate functions. That's where the plus and minus comes in. Remember, whenever we get rid of a squared sign, we accept the fact that a positive or negative value inside of here would give you a positive value out here. So likewise, we're going to do exactly the same thing, identifying that we could have the plus or minus of the square root. I'll show you a real simple example to hopefully clarify this. So consider x squared is equal to 9. X is equal to plus or minus the square root of 9. That is, x is plus or minus 3. Because if x is 3 or if x is negative 3, either way, when you square either of those numbers, you get 9. So they're both valid solutions to this equation here. So likewise, if x minus 2 over 2 is equal to y minus 3 squared, then either the positive or negative of the square root of this quantity in here is equal to y minus 3. Now immediately this brings in the condition that x minus 2 has to be greater than or equal to 0. That is, x minus 2 is greater than or equal to 0, or x is greater than or equal to 2. So that will be a restriction on the domain. So we have 2 functions to graph here. We have y is equal to the square root of 1/2 x minus 2 plus 3, or y is the negative square root of 1/2 x minus 2 plus 3. The reason why I took this fraction and wrote it as 1/2 here was to help me identify the transformations to make this easier to graph. This is a horizontal stretch by a factor of 2. This is a shift 2 to the right. And this is a shift 3 up. Likewise here, this is a horizontal expansion by a factor of 2, a shift of 2 to the right, and a shift of 3 up. So these are various transformations that are applied to the base function root x. So to get an idea of how to sketch this quickly, This is root x. And if I was to stretch it horizontally by a factor of 2, that's what this 1/2 indicates, it would look like this, where each point here is twice as far over as the corresponding point at the same height. That's our horizontal expansion, or horizontal stretch by a factor of 2. We'll then shift it 2 units to the right and 3 units up, placing us here. So what I've drawn out here is this function, and this one's identical, except it is flipped across this axis before we shift it, so it's going to be down here. And as you can see, this is the XY line mirror image of the parabola that is indicated by 2 times x to the minus 3 squared plus 2. So 2 times x to the minus 3 squared plus 2, you'd shift 3 here, you would shift 2 upward, and then we'd draw our parabola from there. And as you can see, this parabola is the mirror image of this parabola, where the mirror is this line y equals x. I'll just draw that without the transformations to make that a little more clear. We will go over 3 and up 2. And then we'll go over 2 and up 3. And this is the vertex of our parabola. And this is the vertex of the 2 radical functions. And as you can see, we have a mirror image as you go across here.